Now that we have learned how to add and subtract monomials, let's learn how to multiply monomials. Remember, monomials means one term, and those single terms can look like 5. It can be a constant. It can also be a variable like x. It can also be two variables that are multiplying like xy. It could be a variable with an exponent, negative 3x squared. It can be a fractional coefficient like 1/2 y. What is not a monomial is 3 over x. Whenever the variable is in the denominator, that's not considered a monomial. And x plus y is not a monomial. It's a binomial because we have two terms here. And addition and subtraction separate terms. So x plus y would be considered a binomial, not a monomial. So let's look at the most basic examples of multiplying monomials. We have a monomial times a monomial. 5 times 4 is 20. Now we can have a monomial times a monomial where that monomial has a variable. So we're always going to multiply coefficients, constants times constants, and then we're going to attach the variable. So that would be 5 times 4 is 20, and then we attach the variable. In this next example, we have constant and, sorry, I don't want it to be green, let's make it yellow, constant and constant, and then we have variable and variable. So 5 times 4 is 20, and x times x is x squared. And we need to remember, right, we remember x squared equals x times x. X to the 5th is x times x times x times x times x. There are 5 of them multiplying each other. So when we have x times x, we can write that in exponential form as x squared. In this next example, we again deal with the constants first. We have 5 times 4, and now we have x squared times x. So if we have x squared times x, x squared is x times x, and x is x. So how many x's are we multiplying? We have 3 x's multiplying, so that's x to the 3rd. Now, there's a much easier way to demonstrate this. We're really taking 2 and 1 and we're adding those together. So there is a rule that says, hey, if we have like bases, meaning we have the same base and we're multiplying, well then we will add their exponents. So there's an invisible 1 exponent there. So in this bottom example, y to the 5th times y to the 7th, we see that we have like bases. They're both have bases of y. We're multiplying, so we are going to add their coefficients. So that's going to give me y to the 5 plus 7, which equals y to the 12th. And think about it, right? Y to the 5th is y times y. There's 5 y's there. And then it's times 7 of those y's multiplying. So we have 5 and 7. So if we combine those, that gives me 12. So we're going to multiply their coefficients. 5 times 4 is 20. And then that's going to be x to the 2 plus 1. So 20 x to the 3rd. We're going to multiply their coefficients. 5 times 4, which is 20. And then we have x to the 3rd and x to the 6th. So that's x to the 3 plus 6, or 20 x to the 9th. When we have x to the 11th times x to the 25th, we have like bases. So we're going to, and we're multiplying those bases. So we are going to add their exponents. And that gives us x to the 36th. Now we notice this one, x to the negative 6 times x to the 10th. Just because the exponent is negative doesn't mean that you change anything. You're still going to add those exponents. Negative 6 plus 10 gives you 4. So it becomes x to the 4th. Again, we have like bases that we're multiplying. So we're going to add their exponents. So we will have x to the n plus 3. Now we can't combine n and 3 because they are unlike terms. So my answer just stays as x to the n plus 3. So when we have negative 7m to the 4th times negative 5m to the 3rd, those are unlike terms. So, but we can combine them because we are multiplying. We would not be able to add these two, but because we're multiplying, we can combine them now. So we're going to first multiply their coefficients. Negative 7 and negative 5 makes positive 35. And then we have like bases, m. So that is 4 plus 3. So my answer is 35m to the 7th. So that can go down. I love it when I want to break it up, it doesn't break up. But when I want to do it, it doesn't ungroup them. Oh, so funny. Ungroup. It happens way too easy when I want it, when I don't want it to happen. All right, negative p times negative 7p to the 3rd. Let's look at those coefficients. Coefficient of p is negative 1. Coefficient of p to the 3rd is negative 7. Negative 1 times negative 7 gives me positive 7. We have like bases, and we're multiplying. Remember, there's an invisible 1 there. So that's p to the 1st. So we'll have p to the 1 plus 3, or 7p to the 4th. Let's multiply coefficients, 8 and negative 7, and then we'll multiply the variables, n to the 1st times n to the 1st. So that gives me negative 56 n to the 1 plus 1, or negative 56 n squared. Coefficients, positive 3, positive 1, which makes 3. Variables, x to the 2nd, x to the 3rd, becomes x to the 2 plus 3, or 3x to the 5th. We've got positive 5 times negative 7, which is negative 35, n to the 4 plus 4, negative 35, n to the 8th. Ooh, look at number 6. Number 6, we have 3 monomials multiplying each other. So we're going to multiply each of the coefficients. Negative 3 times 6 times positive 3. I'm going to multiply negative 3 times 3 first. Gives me negative 9 times 6 is negative 54. Then I have x to the 3rd times x to the 4th times x to the 3rd, which gives me x to the 3 plus 4 plus 3, which final answer is negative 54, x to the 10th. Oh, I think there's more. Yes, that's interesting. Coefficients first. Negative 8, negative 1 gives me positive 8. X to the 4 plus 4, that's positive 8, x to the 8th. 8x to the 8th. Positive 8, negative 8 times positive 1, n to the 2nd, n to the 1st, gives me negative 8 n to the 2 plus 1, negative 8 n to the 3rd. We have negative 1 times positive 7, which is negative 7. We have x to the 4th, x to the 1st, gives me x to the 4 plus 1, negative 7 x to the 5th. Number 10, negative 5, positive 8, negative 40, x to the 3rd, x to the 4th, x to the 3 plus 4, negative 40, x to the 7. All right, now we have multiple variables. This is still a monomial times a monomial. We're still multiplying monomials. We're still going to multiply their coefficients first. That is a positive 3 and negative 3, which gives me a negative 9. Now we are going to multiply like bases. So we can only combine like bases. That is x to the second, x to the fourth. So that's going to become x to the 2 plus 4. And then y to the second is a separate thing. That doesn't combine with the x's because they don't have like bases. So that's y squared. So my answer is negative 9, x to the 6th, y to the second. Everything is multiplying here. 3 times x squared times y times negative 3 times x to the 4th. That's why it ends up being a monomial. When we multiply a monomial times a monomial, we produce a monomial. Probably should have said that in the beginning. That would have been good. Negative 5, negative 3 makes positive 15. We have v and v cubed. We have u cubed and u. So we're only combining those like bases. So v to the first times v to the third is v to the 1 plus 3. U to the third times u is u to the 3 plus 1. So we get 15 v to the fourth, u to the fourth. Now a lot of students would stop there and leave that as their answer. However, you have to put it in standard form. Standard form is alphabetical. U is going to come before v. So my final answer needs to be 15u to the fourth, v to the fourth. This is a really good one. A lot of students make mistakes here. Let's multiply those constants. Negative 4 times 4 is negative 16. We cannot add the exponents of y to the third and x to the third because they are unlike bases. So we'll just put it in standard form. X is going to come before y. So my answer is negative 16 x to the third, y to the third. You cannot. This is the wrong answer. Wrong answer. The wrong answer that most students give here is negative 16xy to the sixth. We cannot combine those exponents because they do not have like bases. And let's try this one. You have a negative 8 times a negative 4, which is positive 32. You have u to the fourth, doesn't have a partner. And then you have v to the fourth and v to the first. So that's, v to the 4 plus 1. So your answer is 32, u to the fourth, v to the fifth. Alphabetical order. All right, that should not be done. Sorry, I think we got one more. Yeah, just one more. So negative 6, negative 7, positive 42, n to the first, n to the fourth, n to the 1 plus 4, m to the second, m to the second, 2 plus 2, 42, n to the fifth, m to the fourth, m, l, m, n. So m comes before. So we do 42, m to the fourth, n to the fifth. Isn't that interesting that I just thought about this? You have m, n, and m is a double hump, n is a single hump, so LMN, LMNOPQ. And then when you have u, and then you have v and w, and notice that v is a single and w is a double. You would think that they would keep those the same, that n, the single hump, would come before the double hump, because you have a single V, a single down, and a double down. MN, yeah, that's so weird. Never saw that until today. Things that make you go, All right, hope that helps. Good luck.